Yep. Thank you, Kanchana. Hi, everyone. I'm Anika Mehnaz of Technology. I did my master's in network systems, and my specialization was in cybersecurity. I got introduced to container technology through an ICT internship program at Platforma Cloud. So my main, it was a project, my main project, the tasks, my main responsibilities as an intern engineer there was to research more about container security and about container sandboxing, the different sandbox technologies. So today what I'll be talking about is container security, and I divided my presentation into two parts. So the first part is container security. I'll be talking about some simple security tools that we can use to achieve container security, recommended practices to ensure container security. The second part is about more, it's about stronger security tools that we can use to protect our containers, container sandbox, and then the different sandbox technologies, and finally a demo. So what is container security? Container security, it's the protection of the integrity of containers. It's a process of implementing security tools and policies, and it protects infrastructure, the software supply chain, runtime, and everything in between. And these are some of the practices to achieve container security. These are very simple: to run containers as non-root users. Then we'll be talking about sitcom, SLNX, pod security policies, and kernel-based logging. So as non-root users, by that I mean containers, they usually run as root by default. So it's very safe. It's safer to run containers and not as non-root users. So what you can do, you can add a user and run containers as non-root users. So these are some of the screenshots I did. I have taken, and then there's another one that you can do is rootless podman. So Podman, it's a daemonless container engine for developing, managing, and running OCI containers on Linux system. So one of Podman's key features is the ability to run containers as an unprivileged user, often referred to as rootless. So here in the screenshot, here we can see that, so we are trying to access the file sshd config. So when we are doing that, the permission is denied. We are getting permission denied. But when we are typing who am I, we are getting root. So Podman takes advantage of user namespaces. So the root within the container is mapped to a non-root UID on the host. So this allows Podman to safely install packages and run services from within the container and not impact the host. And so next one is SE-Linux, security enhanced Linux. So security architecture, it's a security architecture for Linux that provides more control over who can access the system. So when an application or process, which is called subject, makes a request to access a file, which is an object, so SE-Linux checks with an access vector cache AVC, where permissions are cached for subjects and objects. So if SE-Linux cannot make a decision or is unable to take a decision about access based on the cached permissions, it sends out the requests to the security server, SSL server. The security server checks for the security context of the application or process and the file, and the security context is applied from the SE-Linux policy database. And permission, it then takes the decision whether permission is granted or denied. So if permission is denied, an ABC denied message will be seen in var log messages. The next one is sitcom. Sitcom, it's a security computing mode. It's a Linux kernel feature to restrict your application's access. So this feature it's available only if Docker has been built with sitcom and the kernel is configured with config sitcom enabled. You can check using the following command. And if it shows Y, then you know that it's enabled. So your sitcom profiles define what system calls should be allowed or blocked. Pod security policies. So these are just, they define a set of conditions that a pod must run with in order to be accepted into the system, as well as defaults for the related fields that allow an administrator to control. Okay, sorry, I forgot to add the line, but basically it puts policies which pods should be allowed into the system. The next one is kernel-based logging. So this one, it's a very simple tool that you can check the activity in your system. So logs in Linux are stored in var log directory. Files that constantly change are kept in this directory. It turns out logs are constantly changing. So each of these log files stores specific information that we can configure out by their file names. So example, var log auth.log, it contains authorization and security related events. Then kernel.log stores kernel related messages. So kernel-based logging, it can be used for troubleshooting or for security regulations, and it automatically looks for problems using techniques such as pattern recognition or correlation analysis. So now I'll be talking about container sandboxing. So container sandboxing, it's an isolated environment on a network that mimics end-user operating environments. It's used to safely run suspicious codes without causing harm to the host system or network. And in order to observe the code's behavior and output activity. So there's a very famous line, it's very well known, that what happens in the sandbox stays in the sandbox. So it avoids system failures and keeps software vulnerabilities from spreading. So what Sandbox does, it's like an extra layer of security. So how it derives is from the fact that containers, they share host kernels. That's one of the biggest weaknesses of containers. And attacker, if they somehow get access to host kernel, they get into privilege mode, and then it can lead to container breakup. So the solution is to provide a more secure container. It's by container sandboxing to isolate containers from the host operating system as much as possible. So depending on the organization, there are 3 ways we can implement sandbox security. So the first one is full system emulation. So here the sandbox simulates the host machines physical, including CPU and memory, providing deep visibility into program emulation of operating system. So here the sandbox is emulating the end user's operating system, but not the machine hardware. And the third one is virtualization. So most of the sandbox technologies follow this one. This approach uses a virtual machine VM-based sandbox to contain and examine suspicious programs. So these are, so the first one is kernel-based sandbox technology, which is these two, that I mean that they provide protection based on their kernel architecture. So these are Gvisor and Nabla, and the second one is VM-based sandbox technology, which are Firecracker and Kata container. So these two, they protect the kernel based on their, they protect the containers based on their virtual machine architecture. And so all these sandbox technologies, they share one aim, which is to create a real sandbox container that is isolated from the host operating system as much as possible, which I have talked about earlier. So the first one I'll be talking about is Gvisor. So Gvisor was introduced by Google. So it's a secure isolation boundary between the host operating system and the application running within the container. It has developed its own user space kernel called Sentry, which is a central user space operating system kernel that handles most of the system calls. With Gopher, Sentry is able to securely access the file system, and its runtime is runsc, which allows applications to be run on this stack. So this is what Gvisor looks like. It's a simplified version of Gvisor. So you've got Sentry, Gvisor, Gopher, and below it's host kernel, server hardware, and finally the container application. So Gvisor advantages are, so the kernel is written in Golang language that is very secure due to its type safety and memory management features. So Gvisor includes an OCI runtime, which is called runsc, that integrates with Docker and Kubernetes, making it simple to run Sandbox containers. And the third one, it's in Kubernetes, instead of sandboxing each container, an entire pod can be run in Gvisor Sandbox. And the Gvisor disadvantages. So it causes overhead when Gvisor intercepts and handles a system call made by the Sandbox technology. It is not suitable for syscall heavy applications. It causes overhead. And Gvisor has no direct hardware access. So applications that require hardware access, such as GPU, cannot run in Gvisor. And as Gvisor has not implemented all the Linux system calls, applications that use unimplemented syscalls cannot run in Gvisor. Okay, so the next one is Nabla. So Nabla was introduced by IBM. So there are three main layers. The first layer is the application itself, and then all the required operating system components bundled in a Unicornos system, like Mirage operating system, and below that is Solo 5, a general execution environment for several Unicornos and hypervisor types. So Nabla also provides an image builder to create a unikernel image that runnc can execute. Runnc is the runtime of Nabla. Nabla also works by replacing the typical virtual machine hypervisor interface of hypercalls and VM exits with simple system calls. And only 7 system calls are used between the container and the host. And this is how Nabla uses these system calls, while sitcom restricts its interface to being only what the pre-written unikernel runtime actually needs. So by restricting the system calls, it's reducing its attack surface. And all other calls are handled in the user space of the container, which minimizes the possibilities for attacks. And this one is runtime is runnc. I've already said this. Yeah. So this is architecture of Nabla. So you can see the second one is Nabla. The first one, it's like a monolithic kernels, and the second one is using the second one is unikernel. So you can see it's reduced. It excludes many packages, so that's why the size is reduced. And the third one is containers. So Unicornos, what Unicornos is? Unicornos are deployed and run on virtual machine monitors. So Unicornos break the kernel into multiple libraries and place only the application-dependent libraries into a single machine image. So small size lets Unicornos boot in tens of millions and hundreds of instances can be run on a single host. So Nabla advantages are, so Unicornel's most essential properties are improved security, small footprint, high optimization, and fast boot. And minimal attack surface due to unikernel images containing only the application-dependent libraries and an unavailable shell, unless specifically mentioned. Not only is getting a foothold in unikernels difficult for attackers, but the impact of a compromised system is also limited to a single unikernel instance. And Nabla uses run NC runtime, which is OCI runtime spec compliant. So Nabla disadvantages. Okay, so even though the runtime is compliant, the images are not. So for you to use Nabla, you would have to build new containers for all your applications. And it's no mature tool to build unikernel. There's still no mature tool to build unikernel applications. And most of the unikernel applications can only run on specific hypervisors. And porting an application to unikernel may require recoding with different languages and manually including the dependent kernel libraries. And monitoring or debugging in unikernels is either impossible or causes a significant performance impact. So this is a Nabla Tender. So Nabla Tender is something the researchers claim that Nabla Tender uses less than 7 syscalls to interface with the host.
Anika, there is a question.
So
do you want to wait until the end, or do you want to wait until the end to answer the question, or do you want to answer it now?
Is there just one question, or how many are there?
Just one question just came up. I mean, if you are towards the end of the presentation, I can hold it until the end, or you can answer it now.
I can answer it now.
Yeah, question from Obama, and he's asking, can we monitor kernel health? Any of these tooling support monitoring of the kernel health, or do we have to use external tools to do that?
Kernel health?
Yeah.
Kernel health.
Let me ask him to elaborate the question more while you're carrying on. Yeah, keep going, Anika. I'll ask him to.
Okay. Okay. Okay, sure. Okay. So the syscalls serve as the bridge between the user space processes and the OS kernel. So hence, the fewer the available syscalls are, the smaller the attack surface exposed to the kernel. So this is why Nabla is thought to be better than the normal Nabla. So the third one is the Firecracker, which was introduced by AWS. So it's a virtual machine monitor VMM that uses the Linux kernel-based virtual machine KVM to create and manage micro VMs. So it follows a minimalist design which excludes unnecessary devices and guest functionalities to reduce the memory footprint and attack surface area of each micro VM. Firecracker provides a virtualization environment that can be controlled via an AP. Every micro VM provides minimal storage, networking, and rate limiting capabilities that the guest operating system can use. And each Firecracker runs as a user space process. So every Firecracker process is locked down by the sitcom. Sitcom calls, hardware resource, file system, and network activities are strictly limited. And each Firecracker micro VM is further isolated with the common Linux user space security barriers by a companion program called Jailer. The Jailer provides a second line of defense in case the virtualization barrier is ever compromised. So this is architecture of Firecracker, and you can see this Jailer barrier, sitcom C group, then KVM, and yeah. So the Firecracker advantages. Okay, so micro virtual machines, they have a much smaller attack surface, memory footprint, and boot time. And there's enhanced security and workload isolation only available from using KVMs. And the Firecracker is statically linked so that the libraries it runs included in its executable code, making Firecracker environments safer by eliminating outside libraries. And Firecracker disadvantages. So Firecracker does not support hardware pass-through. So applications that need GPU or any device accelerator access are not compatible. Firecracker doesn't support running Docker containers. These are the two disadvantages. Now, Kata Container. So Kata Container is an OpenStack project. The Kata Containers runtime uses a hypervisor to provide isolation when spawning containers. It creates lightweight virtual machines and puts containers inside. So as a result, each container runs on its own kernel, eliminating security limitations of the traditional runc runtime. For each container in Kata VM, there is a corresponding Kata shim on the host, which receives API requests from the clients, example Docker or kubectl, and forwards the request to the agent inside the Kata VM through Gvisor. And initially used as chemo VMs, quick emulator, which were heavy. They were later on replaced by much lighter VM, which is called NEMO, and in NEMO it's about 80% of the packages. And Kata Container Runtime, it's called Kata Runtime. So, and this is a simple architecture of Kata Container. As you can see, they have, these are like mini virtual machines. They each have kernel, and yeah. So the disadvantages. Okay. So Kata Container are OCI compliant, so if they are compatible to work with Dockers, Kubernetes, etc. Kata containers are lightweight VMs that are highly optimized for running containers, and NEMO significantly reduces the boot time and the guest virtual machine memory consumption. And the only disadvantage that I could find is that it may be vulnerable to cross VM side channel attack. So it's an attack where you can hide your communication, and you can still communicate with the two systems and exchange resources. And so from seeing all the advantages and disadvantages, I came up with the best sandbox technology, and I think it's Kata Container. And why I say that, the first reason is it's OCI compliant. The second one, it runs secure and lightweight VMs. And then third one, it has less boot time. But for the best result, what we can do is we can combine these two, Firecracker and Kata Container. So Kata Containers and Firecracker, they are both VM-based sandbox technologies designed for cloud-native applications. They share the same code, but take very different approaches. So Firecracker, it's a specialized VMM that creates a secure virtualization environment for guest operating systems, while Kata containers are lightweight VMs that are highly optimized for running containers. So it's still an experiment. The experiment involves efforts to run Kata containers on Firecracker VMM to bring the best features of the two projects. So now I'll be showing a demo. So before that, so the demo, it involves taking advantage of exposed DockerAPS. So most of you must have heard the crypto mining malware attack. It usually happens through exposed DockerAPS. So what it does, it installs software programs and malware components to take over a computer's resources and use them for cryptocurrency mining without a user's explicit permission. The hackers compromise Docker servers via exposed APIs in order to spread cryptocurrency mining malware. The hackers exploit the DockerAPS code to run an Ubuntu container with the Kinsync, it's a Linux agent, malicious malware. which in turn runs a crypto miner and then spreads the malware to other containers and hosts. So once Kinsing is downloaded on Ubuntu, it tries to connect with CNC servers in a certain location with a different server used for each function. It then attempts to spread laterally across the container network by collecting and using SSH credentials. So using the information gathered, the malware then attempts to connect to each host using every possible user and key combination through SSH in order to download the aforementioned shell script and run the malware on other hosts or containers in the network. So recently we must have heard that Twitter got hacked through this crypto mining malware attack, Bitcoins. So this is a similar process. That's how they do it. So I won't be teaching you how to do crypto mining. Definitely not, that's illegal. But I'll be showing you a very simple example. All of you can do that, and you really don't need to install anything. It's a very simple. Okay. So first, what you have to do is you have to go to this website. It's called Showdown. So in Showdown, you can find many publicly exposed DockerAPS. And what you have to do, you have to create an account, and you have to, the search engine, you have to type product ;Docker. So you type that, you get a list of exposed DockerAPS. Okay, and you have to choose any one of them. Now some will be compromised, some will be not, and we have to see for ourselves that which one will be compromised. So how do you check that? So I'll just choose, let's see which one I can choose. Great. Takes time to upload. In the meantime, I'll just turn this on. Check. Okay, I'll choose this one. Let's see if this works or not. Okay, so this is a normal message. You don't have to worry about this. So what I can do, what we have to do is that you just type /version. Okay. Type that, and if we see these details coming up, like AP version, then there's also kernel version, engine version, then that means it's okay to be compromised. So what we'll do is that go to go to this. So you can use Kali Linux or Ubuntu, anything is fine. So I have already installed Docker here. So you have to install Docker, and so okay. Also have to check if it's running or not. Maybe it's running, so that's good news. Okay. So first what we are going to do is we are going to type this command. And then we're going to come here and copy paste this port number and IP address. So I'll just remove the HTTP.
Why that command, sir? May I know?
Sorry, was there a question or?
So you are using that command, right? Docker-h IP address and port number. So why you are using that command? May I know?
Yes, I'll be explaining that. What I'm going to do is that after I type this command, I will be getting a list of containers. Okay. So I just press enter. So see, I'll be getting containers here, just one container. So usually there are other exposed Docker APIs that we can use to get more than one container. This one is showing just one container. Okay, so let's see if this works or not. So the next command I'll be typing is the same one. This time, instead of PS, I'll put exec -it. The name, the container. Let's just hope this works. Sometimes they work, sometimes they don't. But if it works, it's going to be quite interesting, the result. Okay, let's see. Something should come up.
Anika, you missed the double quote. If you press Control.
Oh, shoot.
Yeah.
Yeah.
Then exit.
Oh, damn.
The closing. Just put Control
Okay,
C
Control.
and then yes.
Ah. Okay, sorry. Let's start. Okay.
Just go up arrow and then
Yeah.
see present already. It's a copy and paste
I'll just type it.
tutorial.
I think copying would help.
Yeah. Okay, let's see if it works now. Okay. So what we can do is we can try. So some will be compromised, some will be not. So let's just try another one, because it usually gives you access to root to the root of another system. So let's just try this one. Okay, these are all just one containers. I was looking for something that's two container, more than one container. Okay, let's try this one. If this doesn't work, then I don't know. I hope it works. Let's see. Let's do one thing. Okay, let's try this one. Okay, now it's stuck. But I wanted to show you guys something interesting. Okay, let's see. Let's wait for a few minutes. If it still doesn't come, then I'll just show you what I was trying to do. This is what happens when you try to use online to demonstrate something. Sometimes it works, sometimes it doesn't. It was working fine, but yeah. Before this, it was working fine. Let's see. Okay, it's not coming up for some reason. So what I was waiting for, so what I was trying to do is that when you type this command, when you try to execute it, so docker -h, the IP address exec -it, and then the name of the container.
Make the screen bit bigger. I think probably people can't see it.
Okay. Okay. Sure. Okay. Looks fine.
Maybe a little bit. Maybe
Okay.
one bit here something. Maybe you can without.
Yeah.
Yeah, that's better.
That's better?
Yeah.
Okay. So what I was trying to do is that when I type docker -h, the IP address, and execute -it, the name of the container, and /bin /bash. So it's a command that I have to put it here. So I can see that after I type it, I enter it, and I get a root access. I directly get, so you can see here after this line, I get root access of the system, this Ubuntu system. And when I type who am I get the output root. Okay. So when you type cat etc os release, you get all the information of the virtual machine, another system's information, everything. And yeah, this is how you use exposed DockerAPS and to gain remote code execution. Yeah, to get to do remote code execution. Yeah, and it's still stuck. But yeah, this would have been interesting if it had worked, but for some reason it's not working now. But yeah, so so that's the end of my presentation. Thank you so much. And
Thank you very much, Anika. There are a couple of questions.
there's another thing. Yeah.
Yeah, go ahead.
So,
Go ahead. No, go ahead. I'll let you finish.
that's fine. You can ask questions. That's fine.
All right, I'll go from the top. I think the person who asked about the kernel health elaborated a little bit more. I think he's asking if the kernel
health.
Can you hear me?
Yes, I can hear you.
Yeah, I think he's asking. I guess I am assuming that he's referring to is any of these tools that you use provide any kernel health monitoring tools, or unless it's the generic question that he's asking about kernel health. I'm happy to answer, but if you want to take a stab at it, yeah, you can go for it.
Okay, I can't see the question. I mean, kernel health, I can't hear it properly. I'm sorry, but kernel health.
Yeah, let's say the applications are running on kernel. We'll start one application or program. Will hand over to application to run on their own time. So there is a chance too many systems calls to the kernel, so that the time the system halted because too many system calls. Is there a way to find related? Is there any way to find that is related to kernel? The question is a little bit, I think there may be some wording mismatch. So if I'm trying to interpret right, it's trying to find out if there are any tooling that
Okay, can we monitor kernel health?
Is the person still on the call?
This one you're talking about.
Is Brahma still on the call?
So are you asking, like, is there any tool to monitor the status of the kernel? Is that what you're asking?
Yeah, let's say that one application is halted because of some kernel related issue. So how we will find that that is related to kernel? So what are the logs we need to check? So that is my question.
Oh, you can check the kernel log. Yeah, okay. You can check the kernel logs, and you can, if it is keep on happening, you can increase.
Yeah, that's how you check their activity. Yes, that's right. That's how you check the events. Anything related to whatever is happening related to kernel, any kind of events. That's how you check it using kernel log. Yeah.
Okay, and is there any issue related to kernel? Let's say that we find some issue related to kernel. So that time means what we have to do. So the many applications are running in our production system. So that will affect that, right? So that time how we will take that that node outside, and how we will do maintenance for that.
Okay, so you're asking, like, after you get the issue, what you can do, right?
Yes, yes.
Okay. So okay, so what I have read so far, most of the security measures, they were taken before an attack happens. So you have to take as much precaution as possible. If you do get if you do get attacked by something, or if there's a kernel issue, then you have to protect your resources. That's all I can say. The last thing you can do is protect your resources, protect your data, and make sure that the data that is there in your system, it doesn't get affected, or it doesn't get into the hands of the wrong people. So yeah, that's all I can say. I hope that answers your question. If what I can do some more research. I'll see if, but I usually get tools that are used to protect containers, to make sure that they don't get attacked. These are like to take precautions. So yeah, but I'll still try to find something, and I'll get back to you, because I think this video will be uploaded on YouTube channel. So I can write something, I can do some more research and write the answer in the comment section. So yeah. Any other questions? Someone is asking what is Showdown. I already said Showdown. It's a website. It's a you can easily get exposed Docker APIs. They're publicly exposed Docker APIs. So if you just follow the same commands, like this one, I did like this one I did like few days ago, and the same commands I used. So it was it got me access to another system that has an exposed Docker API. So you can use the same commands and get access to it. So yeah, and another is, so why are they using GIP ports? Because that's how I learned it. So that's why I was using it. And have a Docker container running, and it is exposed to the public internet. So these are some selected exposed Docker APIs. So I'm not sure if you expose your Docker container to the public, because there's another account, premium account. So if you have a premium account, then you get some more exposed Docker APIs. You get a longer list. So since I don't have a premium account, so I don't know about that. So yeah. And okay. Why it is not on up the container. This one I'm not sure. What do you mean by that? Did you check the Docker log why it is not spawn up the container? And to so you can hear me, right? Hello?
Yeah, Anika, we can hear you.
Okay, I'm just going through the questions. So is it safe to access these Docker containers from your local computer? Any security risk might firing back to you? No, these are absolutely safe. It's absolutely safe. I've done it before. So yeah, you can just this is exposed DockerAPS attack. It's legally acceptable. So you can find many online resources on that. So this is why I wanted to show you guys, because I wanted everyone to try this out. But unfortunately, I don't know why it wasn't working. The right time it went, like the plan failed. So yeah, but you can try this out. It's fun, and just let us know in the comments section on YouTube that if it had worked or not. Can we use containers as distributed data centers? This one, KQ, I'm not sure. I mean, I don't want to answer that because I wasn't researching about it, so I'm not sure. Like, what do you mean by that? Can we use containers as distributed data centers? I'm not sure about that. No. So yeah, these are all the questions, I think. Anything else? And I also wanted to just 1 second. So there's one more thing I wanted to share. So I created a group. It's dedicated to container security. Because unfortunately, I don't know, I didn't find any group. There are groups about Python programming and then Java programming, but I couldn't find a group that was completely based on container security. So if you're into container security or just security in general, so please do join this group. Yeah, try to contribute to the community, help it to grow, and whatever knowledge you have, share it with us. I'll be sharing some of my resources on this group, and yeah, so that's all from me. Thank you.